The contact system CS400E is the latest and most advanced component locator with automatic cut and clinch. The machine provides the operator with the correct component, displays the exact component location, and cuts and bends the component leads onto the board. Insertion rates are typically 3 times faster than unaided assembly, and errors are virtually eliminated. The machine consists of an XY table that positions the boards, a cut-clinch mechanism that cuts and bends the component leads below the board, a dual spot overhead projector, an operator control panel with a color touchscreen monitor, a rotary bin for component delivery, and a programming keyboard. The machine is designed for maximum operator comfort and efficiency. Your operator will appreciate the padded armrests and adjustable footrests, and the 30-degree table angle is ideal for component insertion. The CS400E moves the board, thus the point of component insertion is always the same, directly over the cut and clinch mechanisms. With arms on the armrest, the operator's hands are positioned for quick insertion. The component location is indicated by 2 high-intensity light spots and is precisely shown before, during, and after insertion. Polarity is indicated by blinking 1 light. Component target holes can be oriented at any angle, with lead spans from 1.75 inches down to 0. Now let's take a look at the single most important feature of this machine, the cut and clinch mechanism. It consists of a fixed cutter and a movable cutter mounted on a turntable. The fixed cutter is mounted in the center, lined up with 1 projector spot, while the movable cutter goes to the position defined by the 2nd projector spot. The cutters can be oriented in any angle, in half-degree steps, and any lead span from 50 thousandths to 1.75 inches. 2 leads are cut simultaneously. Let's take a close look at the cutters. Each cutter consists of a stationary inner cutter and a rotating outer cutter. When the component is inserted, its leads pass through the holes in the boards, and then through the square holes in the inner cutters. The outer cutters then rotate, pushing both leads to the edge of the inner cutter holes, shearing them there. The outer cutter sweeps beyond the edge of the hole to clinch the lead. The lead clinch angle is determined by the distance the outer cutter pushes the lead beyond the hole. This distance can be programmed to produce 10 different lead clinch angles. A minimum clinch, typically 20 degrees, is achieved when the outer cutter simply shears the lead and moves no further, as shown here. A small increase in the outer cutter sweep will cause a significant increase in the lead clinch angle. The maximum clinch, virtually flat to the board, results from the cutter sweep shown here. This side view of the cutter shows that the PC board is supported by a standoff pin, which ensures that the cutter does not touch the board. This feature also guarantees accurate lead lengths, because the length of the cut lead is determined by the distance from the underside of the PC board to the cutter shearing edge. Each cutter can move upward or downward on the standoff pin to change the distance from the shearing edge to the underside of the board. This distance can be programmed to produce 10 different lead lengths. The CS400E is the only machine that offers programmable clinch angle and lead length. Clinch direction can be programmed to be either inward or outward. An inward clinch is shown here. For an outward clinch, The movable cutter is positioned on the other side of the fixed cutter. This drawing shows the cutter position for an inward clinch, while this drawing illustrates an outward clinch. Inward clinched radial components do not hold as well as outward clinched radials, as shown here. Other components will hold better with an inward clinch. Having a choice is a big advantage. A major concern when using automatic cut and clinch is the amount of blade surface or footprint that touches the bottom of the board during the cutting operation. The smaller the footprint, the less it will disturb previously clinched leads. The cutter's miniature footprint is practically invisible to adjacent leads. Even on densely populated boards like this one. This view of the underside of the board shows the component leads located on a .100 grid clinched without footprint interference. Another feature of the cutters are their ability to clinch closely spaced leads sideways. In this example, the stand-up resistor lead spacing is .100 of an inch. This underside view shows the leads clinched sideways. In the case of multi-leaded components, such as these SIPs and these dips, normally only 2 leads are clinched to secure the part. However, you have the option to clinch more or all the leads if desired. With clinched leads, the board can be handled without danger of the parts falling out or popping up during wave soldering. Let's see how to set up and program the machine. First, the operator exchanges the parts trays. Next, the rails on the work fixture are adjusted to match the board. Adjustable pin clamps lock the board securely to the rails. Automatic skew correction allows the board to be mounted anywhere on the fixture without concern for alignment with the X or Y axis. The board is then jogged to 2 predetermined target holes, and the program coordinates are automatically modified to match the board's position. Underneath the board, a light projects the hole into the projection microscope. The board is now zeroed for this particular setup. This procedure is required only for the first board of a run. If the machine is turned off before the job is completed, it will remember this setup information and where assembly stopped. When the machine is turned back on, it will ask if the operator wishes to continue the last job. Simply pressing the Yes box on the touch screen will cause the machine to optically locate the board and resume assembly at exactly the right spot. Operators can be easily and quickly trained. The color monitor and touch screen are the focal point of operator communication. They eliminate any need for computer experience or keyboard familiarity. Here's how the machine is programmed. First, a worksheet is filled out detailing the best assembly sequence. This step does not require use of the machine. Next, the keyboard is used to enter machine commands and operator messages as shown here. The table is jogged so that the holes for the component leads center in the scope. Or, at the programmer's option, the light may be jogged to the approximate hole location and the automatic optical corrector used to find the exact position. Using this online programming procedure, you can program about 200 components per hour. The completed program is then saved to the hard disk or backed up onto a 3.5-inch floppy. Programs can also be created away from the manufacturing floor without tying up a production machine. Companies with a large number of board types will find offline programming convenient and cost-effective. Contact System CS400E Component Locator. With automatic cut and clinch.